everyone. In this video, we will walk you through a clear and structured explanation of a naive Bayesian classifier model, exploring how probability theory powers intelligent decision making in machine learning systems. Its fundamental concepts like mathematical foundation, practical implementation, and real world applications will be discussed. Okay, now what a naive Bayes classifier model actually is. The naive Bayes classifier is based on probability theory and it is widely used for solving real world classification problems. Okay, then what is naive Bayes? Naive Bayes is nothing but it is a supervised machine learning algorithm used mainly for classification tasks. It works using probability, specifically Bayes theorem. The reason it is called naive is because it assumes that all futures are independent of each other. Even though these assumptions may not always be true in our real life, the algorithm still performs surprisingly well. It calculates probability of each class for a given data and predicts the class with the highest probability. The mathematical foundation of an algorithm is Bayes theorem. Bayes theorem helps us calculate conditional probability. In simple terms, it helps us update our predictions based on our new evidence. The formula is P of A given B is equal to P of B given A into P of A divided by P of B. The key components are P of A given B, post-A probability, P of B given A, that is likelihood, P of A, that is prior probability, and P of B, that is evidence. Using this formula, the model calculates probabilities of each class and chooses the one with the highest value. Okay, now get into the types of naive Bayes classifiers. There are three main types of naive Bayes classifiers. The first is Gaussian naive Bayes. This is used for continuous numerical data. And the second one is multimodal naive Bayes. This is mostly used for text classification where features represents word frequencies. Third is Bernoulli's naive Bayes. This works with binary data where futures represent presence or absence, like whether a word appears in a document or not. Each variant is chosen depending on the type of data we are working with. And what are the key advantages? First, it is very simple and easy to implement. Second, it is computationally efficient, meaning it trains and predicts very fast. And the third one, it performs extremely well on high dimensional data, especially in text classification problems. And finally, it works well even with relatively small training datasets. Because of these advantages, it is widely used in real world applications. And the real world application follows email spam filtering, sentiment analysis, document classifications, and etc. To be concluded, we successfully implemented the naive Bayesian classifier for text classification tasks. We selected the multimodal naive Bayes variant because it works efficiently with word frequency data. We integrate the full pipeline, including vectorization and classifications. Finally, we evaluate the model using accuracy, precision, and recall to ensure reliable performance. Now, we are getting into the hands-on experience on an example on naive Bayes classifier. Here, create a new Python module and name it as module.py and remove all those steps and start importing the required libraries. Here, we have imported pandas to handle dataset and count vectorizer and TF-ID transformer to convert text into numbers and multinomial NB, which is a naive Bayes algorithm. Here, we are also importing pipeline to combine all steps. We import functions for splitting data and evaluating the models also. And then, we are creating a function called load data where the file path is loaded and the data are loaded as data frame using pandas. And we are creating a train naive Bayes model function where we train a model using pipeline and combining everything and after that fitting the trained data into a model. And then we are creating an evaluate model function where our model needs to be evaluated. Here we use to evaluate accuracy, precision, and recall. Then we are returning all those steps just to print an output. And then here we are creating a main function where the main file path is loaded and x and y columns are splitted. Here 80% data is used for training and 20% data is used for testing. Random states ensure reproducibility. And then we are using print statement to print the naive-Bayes classifier's accuracy, precision, and recall. Then we want to import a data set. So we are getting into Kaggle just to import a data set. Opening Kaggle and typing the data set which you want and download it. Copy file path and add it to the main function here. Now rectify all those errors and run. Here, after rectifying all those errors, the model works perfectly. Here, the naive-Bayes accuracy is 95%, so the model works well as we have trained the lot of data and the model works good. Thank you.